Flicker, what you need to know about it. In the beginning of lighting with LEDs, the main focus was on the light quality. Now the focus is shifting to other effects like flicker. Flicker is fast changes of the brightness of a light source. There are visible flicker effects and not directly visible flicker effects. The modulation of the light can be up to 100%. This is a basically unknown effect with incandescent light sources, since they have thermal inertia. Evolution did not prepare us for this kind of light, since the sun does not flicker. Flicker comes from the LED's ability to react really fast on a change of the input current. Multiple 100 kHz are not uncommon, as you can see in the graphs here. So a LED will react to any change of the input current with a change of its brightness. Badly dampened mains power, for instance, is a problem, or if you have a badly regulated power supply with the ripple on it, or if you're using dimming with PWM, that's all going to generate flicker on the LED. Directly visible flicker, which is usually below 70 to 80 Hz, can lead to disorientation and cause negative effects like headache and even worse. There are also not directly visible effects of flicker that can cause problems. Like the string of pearls effect can be very irritating when you move your head and the light source dissolves into a string of points. Interference with cameras is a problem, and the stroboscopic effect, which can make rotating objects appear to turn slower, not at all, or in opposite direction, can be a real danger in the workplace. There are two common measures for quantifying flicker. PSTLM measures flicker up to 80 Hz. SVM measures flicker between 80 Hz and 2 kHz. A PSTLM of 1 means that half of the test persons can see the flicker. SVM of 1 means that all average test persons can see effects of the flicker. The two different quantification methods are used since flicker above 80 Hz is usually not directly visible. So what does that mean practically for implementing light sources? The EU has limits for the flicker of mains-operated light sources only. Those are in effect since September 2021. A PSTLM of less than 1 and an SVM of less than 0.4 are required. But this affects only light sources which are mains-operated. If you're using a setup with separate LED modules and drivers, those are not affected. But in any case, you should observe at least these limits, since the problems are the same no matter how your light source is constructed, and it's never wrong to be better than these limits. What do you have to keep in mind when measuring flicker? One of the problems is that much of the test equipment on the market uses too low sample rates. This can cause problems when there are higher frequency parts in the light. The same is true for the qualification methods, which fail if you have higher frequency parts in the flicker. PWM dimming can easily fool the qualification methods and the measurement equipment, so typically the measurement is done only at 100% dimming. So there's still a lot to do with the development of better qualification methods and equipment. To better trust your test equipment, it would be nice to have a way to qualify it. But so far, there is no flicker generator on the market that would allow you to generate reliable patterns to test your test equipment. But we are working on such a device. Stay tuned. Thank you for watching and listening. Please don't forget to like and subscribe.